In this video, we will solve problems from the exercise 8.2. So question number 14, the position vectors A, B, C of 3 points satisfy the relation 2a vector minus 7b vector plus 5c vector is equal to 0 vector. Are these points collinear? Okay, so what we are given here, let's understand the concept and the methodology that we're going to follow. The concept here is you're given 3 vectors from the position vector origin O. So vector A, vector B and vector C. So these are 3 points A, B, C. Then we need to show that they are collinear, which is they are in the same straight line A, B and C. So how can we prove that? If we can show the methodology that we would follow is if AB vector can be written as T times BC vector, then AB is parallel to BC, and since B is a common point, they are collinear. So this is the methodology that we're going to follow. Let's proceed. So let us define, let OA vector be equal to A vector and OB vector equal to B vector and OC vector be equal to vector C. Now what is given is that 2a vector minus 7b vector plus 5c vector is equal to 0 vector. Now we can rearrange this as 2a vector minus 2b vector minus 5b vector plus 5c vector is equal to 0 vector. Okay, so further taking the 2 out, it is 2 into a minus b vector and minus 5 times b minus c vector, which is 0 vector. Now we know that our a minus b vector is nothing but ba vector, so it is 2 times ba vector minus, and this is our cb vector, 5 times cb vector, so is equal to 0 vector. Now that means our 2ba vector is equal to 5cb vector, which means we can write ba vector is equal to 5 by 2 cb vector. Therefore ba vector and cb vector are parallel. However, B is a common point for BA vector and CB vector. Therefore, A, B and C are collinear. Question number 15. The position vectors of the points P, Q, R, S are given by these 4 vectors respectively. Prove that P, Q and R, S are parallel. So what's the method that we would follow here? The methodology would be, you have P, Q, or S, which are position vectors. So we need to find PQ vector by using these position vectors and RS vector. If PQ vector is equal to T times RS vector, then they are parallel. So let's proceed to do the problem. So vector OP will be equal to I cap plus j cap plus k cap, and our vector OQ is equal to 2i cap plus 5j cap and our vector OR is equal to 3i cap plus 2j cap minus 3k cap, and our vector OS is equal to I cap minus 6j cap minus k cap. So let's find PQ vector. So vector PQ is equal to OQ vector minus OP vector. So substituting the values of OQ here, 2i cap plus 5j cap minus of OP vector is I cap plus j cap plus k cap. So your resultant vector will be I cap plus 4j cap minus k cap. Similarly, our vector RS is equal to OS vector minus OR vector, which is equal to, our OS is I cap minus 6j cap minus k cap, minus our OS vector is given by, OR vector, sorry, is given by 3i cap plus 2j cap minus 3k cap. So simplifying these two, we get minus 2i cap minus 8j cap minus plus 2k cap. So RS vector is equal to minus 2i cap minus 8j cap plus 2k cap. So this can be further written as 2 times of, or minus 2 times of, I cap plus 4j cap minus k cap. And you can see that I cap plus 4j cap minus k cap is nothing but our PQ vector. So that is equal to minus 2 PQ vector. So RS vector is equal to minus 2 PQ vector. Therefore, RS and PQ are parallel. Question number 16. Find the value or values of M for which M into I cap plus j cap plus k cap is a unit vector. So what we're given is, we are given M into I cap plus j cap plus k cap is a unit vector. Therefore, magnitude of M into I cap plus j cap plus k cap will be equal to 1. So we can say that, when we take the magnitude of this vector here and multiply it with M, it's the same as this. So it's plus or minus of M into, as I'm taking the square root here, I'm putting plus or minus here, 1 squared plus 2 squared, 1 squared plus 1 squared plus 1 squared, which will be 1 plus 1 plus 1, will be equal to 1. So we can say plus or minus M into root 3 is equal to 1. So this implies that our M is equal to plus or minus 1 by root 3. So that's the value of M, or the values of M. Question number 17. Show that the points A, B, C are vertices of an isosceles triangle. So what's the concept here? The concept would be the triangle is isosceles, which means two sides should be equal. So we are given the points A, B and C. So the methodology that we would follow is, we would find, because what we are given is the points, so we can find the position vectors OA vector, OB vector, and OC vector. And from these vectors, we can find vector AB, vector BC, and vector CA. So once we find these vectors, then we find the magnitude of AB, BC, and CA. And if you find any two of the magnitudes are equal, then it's an isosceles triangle. Okay, so let's proceed. So from what is given, we can write OA vector is equal to I cap plus j cap plus k cap. And our OB vector is equal to I cap plus 2j cap plus 3k cap. And our OC vector is equal to 2I cap minus j cap plus k cap. Now let's find AB vector. AB vector is equal to OB vector minus OA vector, and that's equal to 0, 2 minus 1 will be j vector plus 2k vector. Similarly, our vector BC would be OC vector minus OB vector. That would be 2 minus 1 is I cap, minus 1 minus 3 j cap minus 2 k cap. Similarly, our vector CA is equal to OA vector minus OC vector. So that's equal to OA is so minus I cap plus 2j cap. So let's find magnitude of AB vector. So that would be square root of 1 squared plus 2 squared, which is root of 4 plus 1, 5. So magnitude of BC vector would be equal to square root of 1 squared plus minus 3 squared plus minus 2 squared, which is equal to root of 1 plus 9 plus 4, which is equal to square root of 14. Similarly, magnitude of CA vector is equal to square root of 1 squared plus 2 squared, which is equal to root of 5. So we see that AB vector magnitude is equal to CA vector magnitude. Therefore, the given points form an isosceles triangle.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.